by the way, I am Rayan Miko F. Kanoy with my partner over there, our cameraman. And let me tell you first that what we are going to discuss over here is all about theorems in solid geometry. So now, it is stated in theorem 1 that two intersecting planes meet in a straight line. So we have here our solid figure, which have two planes. These two planes intersects each other. If this is plane M here and plane R here, this figure, like this, we see the intersection here. The plane M can be extended and it intersects or passes through the plane R. So plane M intersecting here with the plane R. This is the straight line here intersecting with the plane M and plane R. So we have 2 points here. Here we have 2 points. We have point A here and point B here. And always remember that the plane cannot intersect in one point only. That is from the statement in axiom 3 that two distinct planes cannot meet in one point only. So now it is stated in theorem 2 that a plane is determined by a line and a plane not on it, two intersecting lines and two parallel lines. So now I am going to explain to you first a line and a point not on it. So here we have a stick here, imagining that it is a line. This is let's say that this is line D, and here a point, imagining that it is point C. So here in line C we have point A here and point B. It should be in a plane in which our plane is plane M. So now here we have next is two intersecting lines. So what we are going to need is two sticks, imagining that it is intersecting. So this is our line 1 and this is our line 2. We imagine that in the middle is point A and we have point B here and point C over here. Our next here is two parallel lines. So we are still going to use two sticks, imagining that they are both parallel. So let's imagine that this is line 1 and here we have line 2, in which this line have a point here. Let's say this is point Z and here is point X and Y. They are both parallel to each other in our plane M. So it is stated in theorem 3 that if a line is perpendicular to each of two lines at their point of intersection, it is perpendicular to the plane of these lines. So given a line L perpendicular here, these are line L perpendicular to line 1 and line 2. So here we have, if we are going to use this as our line 1 and this as our line 2. At our point in the middle here, this is our point in the middle, that is our point P there. So to prove that line L is perpendicular to the plane of line 1 and line 2, we will let the plane M here, we will let the plane M be the plane of the line 1 and line 2. So this is our plane. here, and we will let line 3 be any line in M. So it is through P, so it could be any line. So that would be all. Thank you.
Hi guys, I'm Mark Anthony Bialop, and let's continue the discussion from Mr. Bialop. Okay, theorem 4 state that through a point there is one and one plane perpendicular to a line. So let's put the line here, and we call this point is A. To prove that plane M is the only plane through A which is perpendicular to a line, suppose that the plane M through A is also perpendicular to a line. So therefore, straight to the point that the line L is perpendicular to plane M. So we go to now theorem 5. Theorem 5 say that through a point there is one and only one line perpendicular to a plane. So it is opposite of theorem 4. Theorem 5 state through a point there is one and only one line perpendicular plane. So we say that no other line who can pass the plane A. So this will be like this. So this will be like this or this. And theorem 6 states that oblique lines from a point to a plane meeting the plane of equal distance from the foot of the perpendicular are equal. And conversely, two equal oblique lines from a point to a plane meet the plane at equal distance from the foot of the plane of the perpendicular. So now, let's put the line here, and this is the foot of the line that perpendicular to plane M. This is a plane M, and we put another line here, and this point A, and this point P, and in this point that we call point B, and another line here. Oh, come on, oh my god, a line here, and we call this point C, and another line here we call point C. So this distance from here, from the point A to point B, it is called the oblique lines, because in theorem 6 state that two equal oblique lines from a point to a plane meet the plane at equal distance from the foot of the perpendicular lines. So it means that if the distance between point E and point B, then equal the distance from point E and point C. By the way, that's all, and thank you for watching. Thank you for all, and I hope you have learned something, and that's all. Thank you.